All right, good morning. So as usual, I would like to go over some announcement just about what you should really focus on for the rest of this week, and then we'll talk about the review. All right, let's take a look. All right, 3 things you want to pay attention to. Number 1, it will be Lab 0 Part 1. I know it's only due for submission on Friday, but I would suggest you actually try to complete it and submit it as soon as you can. Just make sure you can continue to Lab 0 Part 2. And I want you to pay extra attention to Lab 0 Part 2. I think for Lab 0 Part 1, you were only developing the product class. That one is rather easy, just to get you going, to brush up your memory from the first year. For Part 2, you will definitely see some conceptual jump about how things can actually go more complicated than you might think. Especially for Lab 0 Part 2, we are going to talk about 2 things you want to keep in mind. Number 1 is about reference type, which I'll speak about briefly today, which is I'll speak about throughout the lecture. Reference type as opposed to primitive type. I'll try to draw a distinction to you. And then number 2 would be about arrays, primitive arrays. I'll try to highlight certain things that you should know, you should really review later, maybe on Monday's, next week, on Monday's lecture. Right? You want to get started with Lab 0 Part 2 as soon as you can and finish that. Finally, according to your semester calendar, I'm going to release Lab number 1 this Friday, so you can actually get started and try to apply what you have learned so far, or what we have reviewed. Lab 0 Part 1 and Part 2 are mainly just for spoon-feeding you about what to type, and then make sure you're okay to reproduce everything. But starting from Lab 1 all the way until Lab 5, you're going to be alone, meaning that you have to develop all the classes yourself. But of course, as I said in the beginning of the class, of the course, you definitely can collaborate with your colleagues, right? There's no notion about plagiarism, at least for the labs, and also come to me for help. But I would say try to do things yourself first to begin with, so you can let me know where you struggle. All right, so that's about a quick announcement. Do you guys have any concern, any confusion before we talk about course content? Awesome. So today, my plan will be I want to finish developing that Java program we have, the people projects. I will mostly stay on my iPad rather than referring to the slide. There's some slide number I'll refer you to. But at the end, I'm going to assign some reading for you until next Monday. The idea will be we want to finish the OOP review hopefully halfway through next Monday. That'll be the idea, and then we're going to cover the next topic. All right, let me start with this one here. This is what we left off from last time. We tried to trace the program and talk about how you should understand object creation from the memory, right? That's what we said before. There were 2 things I want to clarify right away. One is the notion about parameters versus arguments. The second notion about variable as opposed to primitive variable. Both are important. Let's start one by one. There are different issues, but I want to talk about them since we're having an example. First, to begin with, is a parameters argument. Let me start by saying I'm being a little bit picky to really clarify 100% what should be parameters, what should be argument. I can tell you that many Java programmers in practice, they may never talk about parameters. They may just talk about arguments. But I would say for the purpose of this course, for your knowledge, let's be a little bit more disciplined about using the terminology accurately. The notion is actually very clean. Okay? Whenever we talk about, let me give you the principle. Whenever we talk about parameters, we are really referring to the context where we try to define the method. Defined methods. That's the context. And whenever we talk about arguments, it's about when we use the method. That's the clear distinction. Once you actually got that principle remembered, it's easy to judge, and I will show to you. I will do some exercise as well together. Define methods, this will be to use the method. Okay, let me give you one example right away. I want you to look at this particular constructor call. Well, constructor is also one kind of method. Look at here. And that one is actually calling this particular constructor over here. What variables do we have over here? You can see we have several variables. We got new weight, we got new heights, and we are passing 72. We are passing 1.81. let's apply the principle I just mentioned. Where is the context of defining the method? Well, exactly in that person class, right? You can see this one here. This is where we define the person constructor, the method. This is where we define that. So these two are parameters. On the other hand, these two over here are when we try to use the person constructor. So they are arguments. In the simple case, arguments are simply like an integer literal or double literal. You can write out the value directly. But in general, you might see sometimes you might pass some variables here as well. But you just got to remember, whenever you talk about the context of using the method, it will be arguments. We only define parameters in a single place, which is over here. Just to clarify one more thing, and we'll do one more example. What about this line over here? This line here, we are using the same constructor over here. So these two, new weights, new height, remain as the parameters. Now we just got two more arguments, 65 and 1.67. They are also arguments because we are using the method. Right? Is it clear about the notion about parameters versus arguments? Okay. And you will see from your slide some similar example. Okay. Why don't I just do one more, just give you a little bit of heads up over here. So you can see we're calling the point constructor. Over here, you can see we are using the point constructor over here, right? Obviously, you can see x and y, they are the param. And 2.5, these values over here, we're using that, so it's arguments. It does not apply just to constructor, any method. Let's just do one more. What about here? Let's say we are calling this particular method here, get distance from. Right? And also, this is the method we are talking about. Okay, similar idea. The other over here, that's a variable. When we define the method, that's parameter. And the P2 and P1 over here, are they parameters or arguments? Which one? Arguments, thank you, because we are using the method. Even though P1 and P2 are not like a 2.5. They are not like an exact value you can write out. But since you're using the method, you're calling that, right? So that they will be argument. Okay? Guys, any questions so far about what I'm trying to distinguish? Since I kind of teach you very clearly, I would expect you to really make that clear distinction to show to me during the test. All right? Let's do one exercise just to challenge you a little bit. Can parameters be used as arguments? Try to picture yourself. Is this possible or is it never possible? If you think that's possible, sketch the idea to me. Or let me try to help you a little bit. Parameters are in the context where we are trying to define the method. So we are talking about in the context of defining some method, can we use those parameters for calling other methods? Can we or can we not? That's basically what we are dealing with. Anybody think we can? You can, okay. Anybody want to speak up for your sketch before I tell you the answer? So this is the kind of the stuff you want to get used to. Sometimes the question itself may not be so explicit, so you want to interpret that in the right way. So as I just tried to help you. Anybody want to try? Otherwise, I'll just tell you the answer. That's not a problem. Okay, let's go over the answer. Since we are now talking about parameters, for example, let's say we have a method, just for sketch. Let's say we have a method n, either accessor or mutator, doesn't matter. Let's say we got some integer I, and then maybe other parameter as well. First of all, I over here is a parameters. And then inside the definition of this method here, is it possible to use I also as arguments? Now maybe it's easier for you to see why we can, right? Because now you may just call another method, maybe called M2. Maybe you say P1.M2, something like that, assuming that's actually valid. And then I can simply use I over here. Apparently the I over here is referring to this parameter. So the way to understand this part over here is like this. Parameter I is used as an argument to invoke method M2. And how do we formally call this P1? Do you remember? What's the word? 2 words. It could be P1.M2, it could be P2.M2. But P1 and P2 are simply different context objects. Okay, just remember. All right? Okay? And don't really feel this part over here to be too weird. It happens way more often than you might think. Later on, once we get to the subject of exceptions, we have to deal with method call or nested method call. Right? That's something we're going to think about. And one more question for you to think about. Let me pose the question in the opposite way. Can arguments be used as parameters? That's the question. I will encourage you to think about this and try to visualize the reasoning process like what I did. I'll tell you the answer. The answer is no. But the more important thing is you should know why. If you really got a little bit struggle with figuring this out why it's no, come to me. We'll speak. All right? Think about it. All right, so that's the first one I want to talk about, which is parameters versus arguments. And the next one, I want to talk about reference variables, which is also worth our attention. Okay? What I will do is I'll just sketch some decoration here very quickly. Okay? Let's now compare 2 decorations. Let's say the first one, I got integer I. Okay? The next one, assuming that we got a person class, which we do, right? Another one is person, let's say P, or Jim, or Jonathan, right? These 2 are valid syntax in Java to declare 2 variables, I and also P. They're both variables. However, you got to be very careful about the consequence of declaring these 2 different categories of variables, okay? And for variable type like an integer, of course, Boolean, float, double, I believe also character, right? For these are the so-called primitive type. So the I over here, we are saying that at the runtime, I can store a or an integer value. Because we declare the type of I to be integer. So that means at the runtime, I is actually going to be a placeholder over here, and whatever we put there must be an integer. That's primitive type, right? That one's easy. We are going to use a consistent notion to interpret this line over here about a P. That one could be a little bit confusing, this one here. How do we interpret this? A common misconception is you think that P is a variable for sure. What does P store exactly? I think you guys pretty much know from the previous review, right? It's going to be the address rather than the entire objects. Okay? Let me write it down, and I'll visualize quickly, and then we're done with this discussion. Number one thing you should know, oh, by the way, so I here is so-called a primitive variable because it's a primitive type, integer. On the other hand, the P over here is so-called a reference variable. And the type, the reference type you can put over here, there are 2 possibilities. Okay? Possibility number 1, it could be a class defined on your own or in your project. For example, the person class that we defined back on Monday. Number 2, which is also a lot of possibility there, will be any Java library class. And I must mention one class to clarify, string class. I think one thing that we used to do, we typically do in the first year, we use the string class so often that people might think string is a primitive type. No, it's not. It's a reference type. That's why I want to mention that explicitly. Any library class you can find in the Java API package, they are reference classes. Okay. String, and also, for example, array list, and etc. Any class you can find. Okay, and let's talk about more about how we can interpret that. It's a reference variable. Oh, let me just finish that definition. Reference variable. Right? Important term to know. And what does that mean? Well, for the primitive one, we said at the runtime, I can store an integer value. Okay. Now for P, at the runtime, again, P can store not a person object, not the entire object, but instead the address. It's kind of indirect of a person object. It's so important to emphasize this, even though you may have known this already. Okay, the address of. And to really compare the visualization, think about P here is still a placeholder. However, that one there is going to store the address, just the address value. And the address value over here, for example, I'll just say 0612. That one there is really referring to some memory location, 0612. And that is the object that's being stored. But the way to visualize it is to say P is actually pointing to this particular memory location. We'll see that kind of visualization very often. That's what I will do. All right, guys, any question regarding the distinction between primitive versus reference variable? I hope that's clear. If you program in any object-oriented language, like even for Python, for C#, they definitely have the same notion as well between primitive versus reference. So you want to have that clear distinction. Okay. Yes, question? Okay, can you have a reference to reference variable, pretty much like a star in C? No, you cannot. That's the beauty about Java. It's simple enough. You don't really have to get, well, okay, let me just, it's a very good question. Just for those of you who might be wondering, maybe you're very good in C. Let me put it here. So this is just a reference to some objects. The question was, can you do what C can do? For example, I might say character, maybe pointer. No. No correspondence in Java. Don't worry, in the test, I'm not going to test you the difference between C and Java, but just for your knowledge. For those of you who might be taking 2031, or you might be, will be taking it later, you kind of need to do such comparison yourself as well. Okay. All right, let me now go back to see what will be the next. Okay. All right, so now we're done for this part here. Parameter versus argument and also reference variable. Awesome. Okay. And what I want to do is to continue with the people projects, right? And then we got still many other things we want to speak. And don't forget about the exercise kind of assign. I will try to allocate at least 20 to 30 minutes. I really want to solve that exercise together with you. It is so important. All right, so let's now develop further. So I'll go back to the person class. Okay, I will also make the source code available to you at the end of today. Okay, let me just make this a little bit bigger so you can see that. So guys, it's readable, right, from the back? Just want to make sure. Good? Okay. If that's too small or too big, always let me know. What I want to do now is to criticize a little bit about this program. Nothing's wrong, but it's just a better style. If you take a look at the way I define, by the way, is this parameter or arguments? Parameter, right? Because now we are defining the method. Don't forget, we're using what we just said right away. The new weights and the new heights are the two parameters. We deliberately chose the names of the parameters different from the attributes. In some way, that's good, because now you see very clearly about the weights is referring to the attributes, and the new weights is referring to whatever value we will get from the user, right? That's all good. But here's the question. The more experienced programmers don't really like to come up with new names. They want to reuse the names whenever they can, right? So in that case, here's the question. What if the names of the parameter and also attributes are the same? Don't worry about this one just yet. It's kind of like a solution for you. But let me show you what I meant. Look at this program here, right? That's what we achieved from Monday. Now I'm going to do some modification. What I will do is I'm going to rename the program. Rather than parameter called new weights, I'm going to rename that to be weight. Of course, this will be weight as well. Similarly, I want to rename this to be height. And this one over here to be height as well. That's the renaming I'm doing. And I can tell you that if you try to do this on Eclipse, no errors will appear. It's actually valid. However, it's really right to do. Let's say we do this. Do you think this will still be a correct program which will set up a person with the initial height and weight? Or it's not doing something correct? Yes? Uh-huh. Okay, yeah. I definitely agree with you. Our intention is to really assign this input value over here into the parameter, into the attributes. That's our intention. But this one here apparently is not doing it. Let's be more precise, and then I can show you how you can check this on the Eclipse. This weight here and the weight over here, are they referring to the same variable? They are not? Well, they are spelling the same.
But the weight on the left-hand side is not referring to
It is referring to something, I can tell you.
it is.
It is. Okay, let me make it clear. So, sorry, I couldn't really change the color of this variable. Just imagine that this weight here and this weight here, they spell exactly the same. So they must refer to the same variable. But now the problem is we got two possibilities. We got either the weights over here at the parameter level or at the method level, or we got this weight over here at the class level, like an attribute. But which one is it referring to?
Right now, it's referring to the parameter because you're not using this stall.
Because I'm not using the, sorry, say the oh, this dot. Yeah, of course, this dot will be the solution. But you're right. At the moment, the weight is referring to, I'll remember to show you this on Eclipse as well, but this weight here is really referring to this one here, okay? This is something called variable shadowing. I'll write it down, and I'll try to give you some visual help on how to remember this. It's called variable shadowing. Okay? What you can think about, I'm not sure if this makes sense. Let's say this class level weight is more like an umbrella. And this weight over here at the parameter is just another umbrella. But apparently, this one here has a larger scope than this one. What variable shadowing will do is the weight is going to refer to the closest umbrella, which is this one here. That's how I remember it. Okay? If that makes sense, awesome. If no, forget about it. But that's variable shadowing. Okay? Okay, let's now check very quickly. Okay, so let me just summarize. So if you actually have the same name over here as like a parameter name and the attribute name happen to be the same. In that way, the variable here is going to refer to the closest scope or the closest umbrella. It's called variable shadowing. All right? How do we see that in Eclipse? I'll show it to you. That's also important. Right? If you go to Eclipse over here, for now, let me say I want to change this one here to be just the weights. This one here, just to be the weight. First of all, no error. Number two, if I try to move, okay, if I try to move my mouse over the weights, it's referring to the weight, the parameter, right? It's not really highlighting weight anymore. If I try to do weights over here, it's also referring to weight here, okay? However, if, well, as you correctly pointed out, the correct solution is to do something like this, to say this dot. Once we have done that, you can see suddenly the weight here is referring to the attributes, which is what we intend to. So that's really syntactically how to use the this dot keyword. But I'm going to explain to you how to understand the this keyword in just a moment. Guys, let me recap. If you only got weight over here without a this, that way, because of variable shadowing, both of the weights are referring to the parameter, which has the same name as the attributes. To fix it, you have to use the so-called this dot keyword for the context objects. In that way, the weight here will be referring to the weight attributes instead. That'll be the correct solution. Okay? That's something to keep in mind. Let me just change that back. Okay, new weights and new weights over here. Any question about variable shadowing? That's also important. Okay? Awesome. Okay? And I'll talk just one more thing about object visualization, and then I'll develop further the code. And it will be on your slide 24 to 28. That one, just what I recommend, you actually visualize the object. You don't need to draw the memory addresses, like what I did, always. I think this will be much easier to actually do. The principle will be you actually draw a box, and then the title of the box will be the class name. And then, depending on how many attributes you actually want to trace, let's say even if you have 10 attributes in the class, you may not necessarily have to put all the 10 attributes in the box. Only put those that you think will be helpful for your tracing. You will actually see me doing that all the time when I trace the program. Let's say we got different attributes over here, and then on the right column here, that will be the instance-specific values for the objects. And then we're going to say Jim is the reference variable that stores the address of this particular objects. Right? You can see that's why the arrow, that's indirect. That's how you visualize a single object. And when I do the exercise together with you today, you're going to see that. Any question about visualizing objects? I think that's quite intuitive. Right? It will be very important for you to know how to do this to some extent, because when you do the written test or later in the exam, you will have to draw on the paper to actually trace the program. So just make sure you can do it. Otherwise, come to me. I got some very nice whiteboard in my office. I can show to you further. Okay, good. What I want to do now is to develop the program further. Okay? And I'm going to change this version over here. If you still want the old version, you can download the source code from Monday. Okay? What I will do now, let me just double check. I want to get, yes, the weight over here. And also, I want to have just the same name as the attributes. But as we said before, because of variable shadowing, we want to get rid of it. So we have to say this dot weight. And also this dot heights. And of course, this part here should be weights, and this part here would be heights. I would say this is the more typical version of the constructor you will see, or even for method updates. Okay? But we're going to talk about how to really understand this. The best way to understand it would be to understand it as the context objects of some method call that's actually using this constructor or method. I'll show you example subsequently. Okay? Let me see what I got over here. Yes, that's good. Okay, let me just switch to here. So from now on, I'm not going to talk about console tester anymore. We're going to focus more on the JUnit test. Okay? You can see we still got our person class over here. Oh, let me make it a little bit bigger, just at this part here. We got the person class, and we got a weight and the height, and we got our default constructor explicitly. Let's say we keep it. And also we got this person constructor here. We got weight, the same name as the attributes. We got height, the same name as the attributes, and we got this dot and this dot. Right? That's the correct version. But now we ought to understand how to use this in your code. We'll trace the program in just a moment. But for now, let's look at the test. The same test as before. We simply want to create Jim and Jonathan, and then we want to compare their addresses. Okay? Let's now try to trace it. We'll trace line by line. The first line. And now you can see me drawing boxes. We want to have Jim, a variable, storing the address of a person object over here. So I'm going to put person here, the title. And the attributes that we want to trace will be weights and heights. I'm going to put W for weights, H for heights. And then, in this case, let's now try to trace further about how to execute this. All right? And this one here is actually going to call the person constructor over here for the first time. Right? Since we are now talking about creating this object and put it into gym, so gym in this case will be the context objects at this point. Context object at this point. That means every occurrence of this over here is going to be replaced by gym. What's more, argument 72 is going to replace every occurrence of the parameter weight, 72, 72. Argument 1.81 is going to replace every occurrence of the parameter 1.81, 1.81. This is just one example call for the method or constructor. We're going to see another one. But what's really important for you to see, for the object creation over here, since we are now trying to create this object and store that into gym, so gym will be the context objects. The context object here is going to replace every occurrence of this in that method being called. That's the important thing. All right? And if you look at that, we have gym.height is assigned to 72. How do you understand the dot notation over here, for example? When you say gym.weight, let's say. For those of you who like C program, right? Dot here is more like an address, it's so-called address dereferencing. That's more like a C terminology. What does it really mean? Look at what address is being stored in gym and go to that particular memory location for that objects. That's basically what it says. If you didn't learn about C, that's okay. Just remember, whenever we say dot, that's more like an address lookup. Look at what's really stored in that reference variable and then go to that particular object. Follow the arrow. So now when I say here, gym.weights, gym.weight is going to be 72. Right? So I'm going to put 72 over here. And similarly, gym.heights, 1.81. It's how you can understand this in the context of constructor. When we talk about method call, like a mutator or accessor, similar. But I'm going to do that anyway. It's important. Let's do, just for completeness, let me do the second one very quickly. Because the point is, the same method over here may be called as many times as necessary. Every time you call the same block of code for the method, you have to instantiate the parameters and this keyword differently, depending on how you use it. Either you use it like that, or you use it like that. It will be different. Let's try that. For the second use, I'm going to execute the second line here. And now, since we are trying to create the object and store into Jonathan, so Jonathan now will be the new context objects, right? And we are trying to create, by calling this constructor here, the same block of code, just the same. So I'm trying to overlay these two colors, okay? So here 65, 1.67, right? So this will be 65 and 1.67 for the different parameters. So this will be 65, it will be 1.67. And the context object is now Jonathan. So every occurrence of this right now is going to be replaced by Jonathan. So now we have something like a Jonathan dot weight. For example, is assigned to 65. Right? So let's visualize that. So we have this particular reference variable Jonathan is storing the address of another person objects. It will be the same layout. Person here, we got weights, we got heights, and then it's going to be 65 and 1.67. And that's it. And of course, after that, when you look at things like that, let's say Jim is not equal to Jonathan. Visually speaking, we are saying that are Jim and Jonathan pointing to different objects. Jim is pointing to this object. Jonathan is pointing to this object. They are different. So that's why this expression over here is going to be true. And assert true, of course, it's going to be fine, and etc. All right? Question? Oh, you have a question? Yeah, go ahead.
You have the same arguments for the parameters when
If you have, sorry, say that again, please.
So if Jim and Jonathan had the exact same arguments,
Oh, that'll be fine. Good question. The question was, here I'm using like a 72 or like a different values for the arguments, right? It could be the case or it could not be because every person may have similar measure or maybe they don't. Let me just write it out just for it to be explicit. Let's say I got another person here. Let's say Alan. Let's say they're different persons, but they happen to have this. They happen to have the same measure as, let's say, Jonathan. New person over here, and then let's say 65, and also 1.67. Okay, third line, the same. Okay, let me just go directly to the visualization. What's going to happen is Alan just going to be another object because we're using the new keyword. Alan is going to point to over here, person. And of course, you got to imagine that you got to call this constructor the third time, right? Every occurrence of this will be replaced by Alan. And then the weight and height over here is going to be 65 and 1.67. Like that. That's what's going to happen. Yeah, it's definitely different addresses, different objects. Of course, you may reassign variables to each other to create aliasing. That's something we'll talk about. Yeah. Okay. The question was about how you can compare objects. I would say up to this point, we are mainly talking about how you can compare addresses of the objects. For that, you just have to make sure you draw the diagram properly and then try to see whether this variable, whether these point to the same object. That's about addresses. The question was about, can we do further about maybe the contents? For example, you can see Jim and Jonathan, they are different objects, of course, and their measure are different. On the other hand, Jonathan and Alan, they are different objects, different addresses. However, their measures are exactly the same. So there is a notion called object equality to redefine the equals method. That's something we will talk about maybe in about week number 4. That's something we'll do. For now, you can just focus on the reference comparison. To really do the object comparison, you will need to somehow customize the equals method. That's something we need to talk about. That'll be more complicated. All right. Guys, any other questions about this? Yes. You mean Jonathan not equal to? Okay, sure. Let me write it down. You're basically talking about how we can compare addresses, Jonathan and Alan. So let's say we say, Jonathan equals Alan. Well, basically we're asking, are Jonathan and Alan point to the same objects? Apparently they are not. So this will be false, right? Yeah. Yeah, try different combinations of creating the objects and try them on Eclipse and see what the results are. If the results are convincing, awesome. If they are not, come to me. Maybe they sound lacking there on the tracing. Awesome. And that's about the object creation tracing. If we're good, let's now talk about methods. I want to talk about 2 kinds of methods. One is called Accessor. Accessor simply means, you will see some summary page on your slides as well. Accessor means the method will return something. There's a return type. On the other hand, there's another kind of method called the mutator. For example, let's say this method here, it does not return anything. In Java, to really specify it does not return anything, you use the void keyword. I'm pretty sure you have seen that before in the first year. But I'm going to review them one by one. Okay? Let's now start with the accessor. Let's now do that first. Let me now go back to Java here. And I'll just give you some simple example. Of course, you will get a chance to program more complicated method in your Lab 0 Part 2 and also all the subsequent labs. In the same class called person, let me just move that to the middle, if I may. Okay, accessor. Let's start with that. Or sometimes they call getters. Accessor is the more universal term. Getter is the more the term for the C-like object-oriented programming language like a Java. But I think they're both acceptable. Okay, the first one, let's say we want to calculate a BMI. Yeah, just in case you don't know about a BMI, right? It's a way to measure your healthy index, right? The formula is going to be the weight divided by the square of your heights. Okay, that's the formula, simple formula. And it's assumed that the weight is actually in kilometers. Sorry, kilograms, not kilometers. Beg your pardon, the kilograms. And the height over here is in meters. But that's okay, because remember we assume the numbers we got from the person creation, they're simply in kilograms and also meters. So for this part, you don't need to worry about conversion for simplicity. All right, just to remind you about the formula. That one is called BMI. If you're interested, you can calculate it for yourself. There's many calculated online. You can try. Let me go back. So what I want to do is to define this accessor here. Okay. Let's now review the syntax. I want this method to be available to external user, so that's going to be public. What does it return? BMI is going to be some division. I would say typically if you do any division in your method, it should be a double. You want the precision. Return a double. And then give the name. Let's say get BMI. And in this case, we don't really give any input, any parameters. Maybe next Monday, once we complete this example, I will try to summarize about some general principle about what you should really supply as arguments, supply as parameters when you define methods. Okay. But to really do it well, it's more like an experience you have to build. But one thing at a time. All right, so over here, what should we do? Well, eventually you want to return something. Well, if you're only still don't feel very confident about defining the accessor, first of all, if you didn't have any return statement, it's going to give you an error right away with a red underline. This is what I would suggest usually, just to get things compiled. We are expecting to return some double, right? Just say double, let's say result. Because it's double, default value is 0.0. Return the result. That's the minimum you can do just to make it compile. Did I spell it wrong? Oh, beg your pardon. That one should be empty, right? No parameters. Yeah. So you can see in the first line, I declare some variable, and the variable type is corresponding to the return type, and I'm returning that. Of course, this is syntactically correct. It compiles, but it's not doing anything right. What should we do to compute? Well, according to the formula, it's going to be result is assigned to. We are now going to refer to the weights and the heights of the current person, the context objects. So that's why we're going to use this. And I'll show you that in just a moment, to how to trace it. Weight divided by the square of heights. Okay, I just want to make sure the multiplication in this case will be done first. All right, that's it. Yes? It's a very good question. The question was, is this keyword in this case really necessary? Okay? The answer is, it's not necessary. Either you can put it or you don't need to put it. You only put the this keyword explicitly if you're worried that you might have variable shadowing, like what we saw before. If you don't have any potential of the variable shadowing, you don't need to put a this. However, I would suggest, in this case, I will still put a this. I personally like to put a this because I can very easily, more conveniently think what the context object might be. You will see, it's easier for the tracing. It will still work. Let me make a note over here. Removing this dot here will still work because there is no variable shadowing over here. You can see there is no parameter over here that has the same name as the attributes over here. On the other hand, you can see for this one over here, the use of this would be mandatory. Otherwise, you get a variable shadowing over here. Actually, that's a very good question. I like that. Yeah, very good. Guys, any questions so far? If no, I'm going to move on to developing some test cases, and then I want to trace it. Okay? Yes? Okay. Can you actually make the result undeclared? First of all, leaving things undeclared is not a very recommended practice. You want to be explicit about what the initial value is, even though it might be the default. Let's say if I do that, Eclipse somehow will not complain because you're trying to reassign that right away in the second line. So that's okay. But I think in some occasions, let's say you don't really initialize it. Let me show it to you. Maybe that's what's going to work. So let's say, for example, if I say integer, let's say double D is assigned to, for example, result multiplied by 2. Okay, now you got an error. Because in this case, even though we know result is going to be assigned automatically the default value, but Eclipse forces you to really give some initial value before you ever first use it. That's a nice one. So I'm going to comment this out. I'll put the comments here. This would be an error because result must be initialized before its first use. Yeah, I like you guys' question. You just make the review so much better. Okay, and let's now move on a bit. I will at least finish the accessor over here, maybe mutator. I need to leave until Monday, but I really want to go over the aliasing example together with you. Okay, I'll get there. Okay, I'll watch out the time. Okay, so now I want to trace, actually before I want to trace very quickly together with you. Okay. Oh, sorry. All right, so we got our get BMI over here. And this will be test number 2. And I already included code over here for you, so I will encourage you to type it out yourself, all right? Which you did already for lab 0 part 1. Okay, let's now try to trace it. Let's first of all understand what the test is trying to do. We create Jim, we create Jonathan. And then, we're using assert equals, okay? I would say at this point, before we introduce about the equals method, whenever we're using assert equals, it's only for comparing numerical values for now, you can assume. Okay? Let's try to understand the 3 parts over here. That's really important. Right? There are 3 parts. Part number 1, part number 2, and also part number 3. All right? I believe that might be mentioned in the tutorial as well, but I'll just repeat that. The order is really important. The first part over here is about what we expect. The second part is what actually got returned from the method you implemented, which may or may not be matching the expected value. Number 3 over here, since if you're only comparing integer against integer, you don't need this part. If you're comparing double against double, you will need to give so-called tolerance. And for those of you who might have taken some physics course, maybe there's something called epsilon, something like that. Okay. But don't worry about epsilon too much. Tolerance. Briefly speaking, computers are in binary. But when you talk about double, like a numerical value here, they are in decimal. You cannot really have perfect representation of decimal in the binary. So that's why you got to give some tolerance for the imperfection. That's a brief story. If you want to know the complete story, it might take you another course on the numerical analysis. Let's not bother. All right. All right. So these are the 3 parts. It's so important for you not to mix up these 2. Always go for the expected value followed by the actual value. For your subsequent labs and also for your programming test, the way I'm going to give you some specification is by using lots of equals, assert equals, or assertion. You want to know how to interpret them. All right? Good. Understanding this, let's trace the program quickly. Let's now try to do line by line again. And this time I can do a little bit quicker. Okay? Let's say, Jim, I want to create this person here. We know that pretty well. Why don't we do that? I cheated a little bit by having box ready. So it's going to be 72, 1.81. And the second one over here will be Jonathan, 65, 1.67. 65, 1.67. And now we want to trace these two method calls. I'm going to highlight it. Number 1 here, number 2 over here. I want you to look at these two method calls right away. Two things. Number 1, they are calling, oh, let me use a different color. They are calling the same method, get BMI, number 1. The same method is being called, number 1. Number 2, the context objects are different. Jim and Jonathan here, right? You can put these two over here. The context objects, different. That's kind of the unique phenomenon for OO. Even though you're calling the same method, even with the same arguments, but if the context objects are different, the consequence or the outcome might be different. So always pay attention to context objects. Let's try to trace the program together for this one here. What we'll do is, let's do the first one. When we say Jim dot get BMI, let me write it down here. Jim dot get BMI. All right, over here. And we know that it's going to call the get BMI method over here. We know that. No input, that's good. And the context object over here is Jim. Context object. That means we're going to replace every occurrence of this by Jim. So that's why I said before, it's better to actually include the this in this case. I think someone actually pointed out. Okay. All right, so we're going to replace every occurrence of this over here by Jim. Everything becomes so clear because now for us to assign this internal variable and return it, it's going to be Jim.weight divided by Jim.height multiplied by Jim.height. So we're going to calculate the BMI using these two numbers. And the number will be whatever I list over there, right? So this will be the calculation. What if we go to the next one? Let's say the next one would be, let's say maybe blue. The next one, let's say we want to do the, sorry, not this one. We want to say Jonathan.get BMI, right? If we say Jonathan.get BMI, the context object now has become Jonathan. That means every occurrence of this over here is going to be replaced by Jonathan. And when we do the calculation here, it's going to be Jonathan.weight divided by Jonathan.height multiplied Jonathan.height, basically over here. So that means the number will be different for the BMI. It's a very quick tracing about, number 1, how you can visualize object creation. Number 2, how you can replace the this according to what the context object is. Any questions? All right. Think about it. I will leave this mutator over here to Monday. I want to do two things, several things. First of all, can we just try attendance check very quickly? I believe the issue has been resolved. I believe. Okay. And then we're going to talk about aliasing and do that exercise. I really want to do it. Guys, give me a moment. I will start the class 2030. And then, of course, I'm going to switch to that attendance taking page. Over here, and the poll. There we go. Are you able to join? Awesome, good. I think we should be able to start taking real attendance maybe from Monday, potentially. I think I know how to make it work. So just enter any, I'll try to make the question more intelligent, not this dumb, but I'll try to design some good question next time. So you can also learn something at the same time. Yeah? Maybe I'll talk to you after class. Okay, awesome. All right, let me see. Okay, so we got 32. Not too bad. I would say if you guys always show up, you got your 5%. How nice, right? More than happy to do so. Thank you. All right, I think starting from next week, I will do this not necessarily every class, but sporadically. Maybe every time, maybe every other time. So just make sure you got it ready. Let me close this, and then I want to move on to aliasing right away. And then I will complete this example maybe next Monday instead. Let me just close it. Awesome. Okay. I got about 25 minutes-ish, right, before the end of the class. I want to cover this well, aliasing. I want to start with the basic. What's really confusing about aliasing is aliasing only occurs for reference variable, not for primitive. Let's do something just to warm up, okay? And then we'll do that challenging exercise I assigned to you. We'll do it together. Let's talk about what this one is easy. We got this one here. Let's try to trace it together quickly, right? We got a placeholder called I, assigned to be 3. What does it really mean? When you say J is assigned to I, that means you have a variable J, copy the value of I onto J. So copy the value here, like that, right? And then if you got another thing over here to say K is assigned to 3, that's just another one. So we got 3 copies of the same value 3. That's at the primitive level. And of course, if you try to compare I is equal to J, and these, you're simply comparing what the value is inside. And not surprisingly, they're both true. That one's easy. I don't want to waste too much of your time. Just make sure you understand what's going on here. Yes?
In the register, are they all pointing to the same 3? Or when I say pointing, the address they're going to, is it all located at the start?
Oh, okay. At the memory level, I believe since you're trying to assign them differently, it's a good question. I think they should be like a different variable, like a different register, different locations. However, I think it depends on the compiler of your language. For example, some compiler may try to be smart. They said you're basically using the same value. Why not, actually, right? Yeah, exactly. So I would say that may be the more at the compiler level, so we don't need to worry. Good question. Let's now take a look at what's happening here, right? Just to get more idea, okay? Let's assume we have the point class that's in your slides. The first one, okay, let's try to trace it. P1, store the address of some point over here, and we assume that we got X and Y. 2 and 3. Okay, and then what does it really mean to say P2 is assigned to P1? I want you to compare this with J is assigned to I. Okay? When we say J is assigned to I, you copy whatever that's in I onto J. When you say P2 is assigned to P1, you copy whatever that's in P1 onto P2, right? Similar. But what you're copying is not the object itself. You're copying just the address. All right? So now it's very easy to see. So now P2 is going to be assigned whatever address P1 has. Diagrammatically, P2 is now going to point to wherever P1 is pointing to. I want you to make sure you understand this line here pretty well. That's really the key. Okay? Continue. And we got P3 over here. P3 is now pointing to this one over here. And point. We got X, Y, and 2 and 3. You can see even though their attribute values are the same, but they are different objects. All right, let's try. P3 equals P1. What should that be? False, I agree. Because they point P3 and P1 point to different objects. Should be false. Oh, by the way, what is this? Or, okay? Because we know one side is false, so it can still be true if the right-hand side is true. I'll try to review this logical operator with you, maybe a little bit later. Okay, and then we say P3 is equals P2. True or false? Also false. Thank you. Just look at the diagram. Pretty easy. All right, it's going to be just false. And I think what I'm trying to do over here is just to compare the attributes directly, X and Y. X and Y. You can see P3.x, for example. P3.x, P3.x, which will be 2. And P1.x, P1.x will be 2. 2 equals 2. Right? So you can do that comparison yourself. That was easy. Okay? Any question about this level of detail? Everybody's okay? All right. And I think you guys are ready to do the exercise. I'll guide you. This one here is only just for you to get prepared for using array, but I'm going to do that directly just to save time. Let's go to the exercise directly. And I really want you guys to try. I should have printed out a copy for you, but if you have a piece of paper, please have them now. We'll do face by face together. That could be for the rest of this class. Let's do it properly. Yeah, grab a piece of paper, and then I'll give you guys about 1 to 2 minutes. I want you to visualize just this part. Just this part. And I think that you can assume we only got 2 attributes in the person class. As you can see from the exercise sheet, we got the name, and also we got the age for the person class. That's what you can assume. Okay, only do this part. I'll give you 1 or 2 minutes. And yeah, I think I should close this. Okay, I'll just switch a bit. Yep. All right, good. Yeah, to save time, at the same time, I'm going to put down the solution on my iPad. If you're still doing it, just don't peek, all right? What you should really notice first is about how many boxes you should really draw, depending on how many new keywords you have, right? All right, let's now do that first. But meanwhile, you can keep doing what you're doing. Okay, just give you 1 more minute, and then I think I'll be done also very soon. Okay, we got the name and age, name and age, name and age. And we got Alan, we got Mark, we got Tom, we got Jim. And by the way, what should be the age? 0, default value. If you look at back the code in the exercise sheet, it's just default value. Just quick check, right? Good. It's intentional, right? And then I'm just going to make sure you. One thing to show to you, a very common mistake I saw my student make, maybe they can still actually get the idea, is to point the arrow the wrong way. No. All right, not this way. Alan stores the address of these objects. This one here, and also Tom. Finally, Jim. That should be what you would get after visualizing these 4 objects, okay? Good. I assume everybody's okay up to now, all right? The next one is something that we really want to make sure you know how to interpret. This one here. First of all, you want to understand this part over here. Oh, let me use a different color. This part over here. Okay? Let me put it down here. When I say person, this, and also persons 1, all right, and etc. Let's say this is only a decoration. How do you understand this decoration over here? Number 1, it is an array. Number 2, this type over here tells you what every slot or what every index of the array would store. I'm going to write it down, but every index in this particular array is going to store the address of a person object. That's how you interpret that. All right? I'm going to write it down. This part over here, it tells you each index of the array stores the address, not the object itself, but its address of some person object. It is so important for you to know this because you will see that something very similar in your Lab 0 Part 2 and in many other occasions. Finally, what does this person's one over here? Before I point to you. Is a reference, but is it a reference to an array or a reference to a single person? Into the array. It should be to the array because when you think about it's a person's one, it's a reference variable. But its type is not just person, but rather a person array. So what's going to happen is person's one is going to store the beginning address of an array that stores person objects. That's how to interpret that. All right? Already done. Person's one will stores the beginning address of the array. And like what I said in the orange, for that particular array, every index stores the address of some person object, right? And you can see there are two levels of indirection over here. You gotta be careful, all right? Any questions so far? Are we okay? All right. That's about this part over here. But what about this part? I'm sure you have seen this kind of syntax before, right? That's how one possibility of initializing your array. But here, Alan, Mark, and Tom, they are not like a simple value, like a 1, 2, 3, like a numerical value, they are reference value. But idea would be very similar. I would suggest, I'll help you in rewrite this particular part, okay? Let me just get rid of this for now. I want you to think about this part over here is equivalent to the following. Person array, and then persons one is, since we ultimately want to store 1, 2, and 3, will be new person array, size, should be square brackets. And of course, this will be the kind of syntax you want to know how to write. I think I also reviewed that in the Lab 0 Part 2. Make sure you can do that in the lab and the programming test. That would be the first one, just to initialize the person's one array with all the null values in each index. And then you're going to say the index 0 is going to store Alan, index 1, and index 2. Right? So it's going to be persons 1, index 0 is assigned to Alan. And by the way, we just spoke about what it really means to really have variable assignments for reference variable. We'll talk about it. Just give me one moment. Let me finish this, and then I'll get to you. And then you also got persons 1 at index 1, assigned to Mark. And let me try to see if I can fit it in. I should be able to. Give me a moment. There we go. And also we got persons 1 at index 2 is assigned to Tom. I'll take a question first. Go ahead.
You declared the person size for each it starts with 0,
If it starts with 0, go all the way to 2. How many numbers are there? 3. So that's why it's 3. Oh, I see. So the 3 here, okay, maybe that's something I should mention later. The 3 here is about a size, not the maximum index. The 3 here is about the size of the array.
So the size of the index numbers are different.
Or thinking this way. Okay, I'm glad you mentioned that. Maybe the confusion for others. Okay, good. In general, let's say let me use person again, for example. Person array, let's say PS, new person. Let me use a general number. Let's say not just a specific number. Let's say just, let's say some constant. Let me say max. assuming that max is defined somewhere. Okay? What does it really mean? Two things. Number one, there will be max indices in the array. Number two, the range of indices will be starting from 0 all the way up to max minus 1. Okay? And then, how do you really get to this value? You can do ps dot length. So that means if you do ps dot length equals max, that one there is going to be true. Right? And the largest index, just for your information, the largest index is going to be ps dot length minus 1. Yeah. Hopefully that answers your question, right? Good. Yeah, guys, important. If you got it wrong, you're going to run into array index out of bound exception in the programming test, which is not fun. All right? Good. Anything you really find kind of weird to you, just raise your hand. So I think it's really nice. We can clarify all of them. Okay, we got about 9 minutes. I'll do as much as we can. Yes? Sorry? Number one? Okay, so for example, let's say max happen to be 10. That means you got 10 indices in the array, which will be starting from 0, 1, all the way to max minus 1, 9. That's what I meant. Yeah. Max can be any number. That's what I meant. Yeah. Oh, one more thing to mention to you guys. At some point, I'm pretty sure I will give you some question related to it, but I'll try to give you some example later. But review what this operator does. By the way, what does it do? Do you know?
It returns the
Remainder, exactly. Okay. I'll write it down, but you should really know how that works. You might see that operator at some point in the test. It calculates the remainder, absolutely. Or to be more formal, some people call the modulo operator. And I think once you get to EECS2030 about data structure, whenever this one particular data structure called a circular array, to really save the space, you want to really have a fixed size array, but to be more flexible in terms of the indexing. So you have to use the modulo operator to do it. If you take 2011 with me next turn, then you will definitely see that. I don't know, but just for your information. Alrighty, let me now go back to this part over here. Now, how do we interpret this? So don't get me wrong, nothing wrong with the original code, but I'm trying to help you understand what exactly this one is doing. Index 0 is going to be assigned to Alan, index 1, and etc. Let's try to understand this one here. How do we visualize it? We're going to have the persons 1 array is going to be pointing to the beginning of an array of size 3 over here, right? It's going to be of size 3. Index 0, 1, and 2. It is this part. Initially, all the values will be just null. Initially. All right? And then, how do we execute this line here? Here, we are saying that we're going to copy the address of Alan into the first index of the person's array. Right? I'll write it down just for the first one. This one here is to say, copy the address store in Alan to index 0 of the array. Alan is pointing to this particular object over here. If we want to copy the address of this object over here to here, diagrammatically, it's going to say, rather than pointing to null, is actually going to point to wherever Alan is pointing to. We are following just the same notion of reference copying. I hope it's not too much, right? Good. Let's do something similar. Here, and also here. Similar. And the second index, index 1, rather than pointing to null, is going to point to wherever Mark is pointing to. And then the third one over here is going to do that. All right? Like that. And then, oh, you're right. Thank you. You're absolutely right. Absolutely. Thank you. Should be pointing to wherever Tom is pointing to, for sure. Okay? And then, let's now move on. Okay, I got about 5 minutes. We'll do as much as we can. Maybe I'll get to a certain point. You can try to see if you can complete the rest, and we can review it Monday. Okay? Might be nice. What about the next line? Next line is pretty standard, right? We are basically trying to create another array, persons 2, and that one we have a precise number for the size. It's going to be whatever the size it is for persons 1. What is persons 1.length? 3, thank you. You can see persons 1 is this array, 1, 2, 3, right? So that should be 3. Let's make a note for us. Let's draw that array. That one there is going to be persons 2 pointing to the beginning of an array whose size is the same as persons 1, which is 3. And for simplicity later, I'm going to put 0, 1, and 2 here instead. All right? And this part over here is going to be the fun, which I'm going to highlight. Ooh, what is this? It's a loop, right? Let me help you a bit, and then we will be done for today. I'll help you. I'm not going to trace it completely today. It's going to take a little bit more time. But I'll help you. Try to do it over the weekend and come back, check your solution. Okay? How many iterations are we going to run for this loop if by looking at the header of the for loop? 3. How did you figure?
Because you start from 0 and then you're going to less than person 1.
Yes, strictly less than. That means you go for 0, 1, and 2. Okay, let me make it more explicit for everybody else. Very good. Let's take a look. You can see here, persons 1.length, we know pretty well it's 3. We go from initially 0 and then 1, and we got to be strictly less than 3. So these will be the 3 iterations we're going to run. Iteration number 1, we're going to use the value of I being 0. Iteration number 2, we're going to use the I value being 1 and then 2. 3 iterations. So you're going to execute the same block of code in the body of the loop 3 times. Question? Yeah, you can definitely, yeah. So the question was, can you actually just write them down explicitly with the exact index number rather than having a loop? I see what you mean. It's different. It's a good question. Do you mind saving this question for Monday and ask me right after I trace it precisely? It's an important question. Okay, guys, I'll sketch very quickly. It's a very good question. Let me just sketch very quickly. The question was, eventually you will see you can see this is separate array. Why don't we simply say persons 2 is assigned to persons 1? What that would do is it's going to assign this directly to this array. That means we are sharing completely the array. Ask me once more. I'm going to make some remark on Monday. Okay, can we rely on you to be here on Monday? Yeah, good. Okay, try to. Okay, no problem. I'll try not to ask you right away 8:30. That might be too early. That's okay. All right, guys, I'll give you one more hint, and then I'll call it a day. Knowing we're going to have 3 iterations over here, let's just do the first iteration for you. For the first iteration, I is going to be a value 0, right? Let's try to see what this line will become. This line over here. I being 0, what that's going to happen is we're going to have, let me put it here. persons 2 at index 0 is assigned to persons 1 at index 0, right? So that'll be the first iteration. And this should be something you know how to do already, right? Let me mention it verbally. Copy whatever that is stored in persons 1 at index 0 onto the index 0 of persons 2 array. Diagrammatically, I'm not going to draw that for now. You want to try that yourself. Diagrammatically, persons 2 at index 0, rather than pointing to whatever it is currently pointing to, it is going to point to wherever index 0 of persons 1 is pointing to. It sounds a bit confusing, but I'm saying that very precisely. All right? Guys, thank you. And then I would say complete the tracing. I'm going to do it again on Monday, and we'll finish the review. All right, see you next Monday.